S. And so the setting later in the seminar will be that we'll have C mapping down to S, and this will be a nodal curve, or really a log curve, as we'll see later on. And then we're going to have CU mapping down here, and this is going to be smooth. And so this CU thing has, we can take this pic 0, which will give us the A, and then we can go back to trying to build. So if we have this picture, we can ignore this corner and take the pic, and we get a picture like this. So let's take this to be pic 0 CU over U. And then the question is, what do we fill in the right-hand corner? Everything I've done so far with this Picard functor, well, we can just apply that to C over S, and it will give us a group algebraic space, but it will be very far from being proper. And that's really the thing that will be fixed by taking the logarithmic Picard. So if we just take pic C over S here, then it's indeed it gives us a smooth separated group algebraic, sorry, a smooth group algebraic space over S, but it's not proper. And if you take the log version, then it will, under some assumptions, become proper, and that's the goal of what we want to understand. And then there's a question of, like, is this thing representable? And then that's the business with this log algebraic space thing. So I have like 2 minutes left. So if instead, so maybe I've been a bit silly in taking time to build the algebraic space by doing the sheafification business, whereas if we'd been content to work with a Picard stack, then we wouldn't have had to go through any of these shenanigans. The advantage of working with the algebraic space is that you get an actual abelian scheme at the end, so that's kind of nice. You get some familiar gadget. So this Picard algebraic space is, in some sense, in a fairly accurate sense, like a coarse moduli space of the Picard stack. I'm generally not a big fan of coarse moduli spaces, but this is a very nice coarse moduli space. And the point is that the inertia of the Picard stack is smooth. It's everywhere because these curves are have reduced connected geometric fibers. The inertia is always GM, and so you're just dividing out by like sort of the same inertia everywhere. And so when you take this coarse moduli space, it's very mild. You just divide out by the inertia, and then you sheafify, and it becomes representable. So whilst this is a coarse moduli space, it's a lot better behaved than many that get used around the place. Okay, so now I will stop, and we will have a half-hour break before. Is it half an hour break? And then Salvatore will tell us what I was actually talking about. Shall I write the titles for? So I'll just write up the titles for the next time, and you can get all excited and volunteer if you get something at any point in the afternoon.
There should be coffee outside. I haven't checked, but there should have arrived.
Ja, want zelfs in het voorbeeld wat hij gaf met een conic over zich spec R, dan hebben ze een risicotopologie volgen, gebeurt er niks meer, want spec R is gewoon een punt. Dus als je dan rijdt alles boven is een risicotopologie, maar